Hello students, now I am explaining about the sinusoidal signal. This is under the classification of basic signals or signals and systems. So first of all, sinusoidal signal, let it be denoted with x of t or x of n. X of t is equal to a cos omega naught t plus or minus pi. This is in cos. X of t is equal to a sin omega naught t plus or minus pi. This is in sign replacement. Okay, and next we know about the a1. A means amplitude, and omega naught t, omega naught means frequency, okay, and pi means phase shift. Phase shift is maybe positive or negative. Then this is also same as a means amplitude, and omega naught t means fundamental frequency, and t means time period. Both are same. Phase shift may be plus or minus. Then we need to know about the fundamental sinusoidal signal. Here I am starting with cos. Cos will be started with 90 degrees, right? Then sine will be started like this. By using discrete graph of sinusoidal signal means so this is the discrete sinusoidal signal. In this place we can write only 2, 1, 2, 3, minus 1, minus 2 and minus 3, that's it. But in continuous manner of sinusoidal signal, we need to capture every point of or every instant of time. This is the continuous sinusoidal signal and discrete sinusoidal signal. In discrete time, we can't measure the instant, every instant of time. In continuous manner, we can capture a particular instant of time also. So we need to know about the relationship between fundamental frequency and time period now. Omega naught is equal to 2 pi f. Then we need frequency means what will we do? Omega naught by 2 pi, right? This is frequency. Then time period means 1 by f. We can replace f value here. F means omega naught by 2 pi, right? Then 2 pi by omega naught is time period. Time period is 2 pi by omega naught. Here, for example, so W naught is equal to, or omega naught is equal to 2 pi f, right? We need frequency means f is equal to omega naught by 2 pi. Then what is the basic formula of time period? T is equal to 1 by f, right? That implies 1 by frequency value we can substitute here, omega naught by 2 pi. Then what is the answer? 2 pi by omega naught, right? The final time period is 2 pi by omega naught. For example, in this place, a cos plus or minus a cos pi pi will be there, means what is the frequency here? What is the frequency here? Omega naught is equal to 2 pi means we can substitute here 2 pi by 2 pi. Then it will be cancelled, means t is equal to 1, right? So a cos t plus or minus t means 1, right? Here a cos t will be there. Here I am taking one example. X of t is equal to a cos t. First of all, we need to compare here. A cos t will be there. There is no phase shift, and frequency we can assume 1 means a cos t will be we get, right? So a means amplitude, W naught or omega naught. W naught is nothing but omega naught, right? In some places they are calling like omega naught or W naught, but must and should we need to call omega naught. Okay, omega naught is equal to 1 means time period is equal to 2 pi by omega naught. Then substitute that omega naught value. 1 means time period how much? 2 pi. So time period is 2 pi, right? We need to repeat the cycles from 2 pi times. We need to repeat the cycles from 2 pi time means the cos value will be getting. From peak to peak we can take it, or one complete cycle. One complete cycle is one upper signal and one lower signal, or one positive side and one negative side. This is time period we can take, or this also. So here we are drawing some graph for a cos t. Maximum the cos will start from 90 degrees, right? Cos will start from 90 degrees, and then this is the sinusoidal signal. Cos means 90 degrees means cos will start at maximum at x of t is 1. Then one complete cycle from peak to peak, the time period will be 2 pi, right? The time period will be 2 pi. By seeing this graph also we can trace the a cos t value, right? The amplitude must be 1, and this is a sinusoidal signal. The time period will be 2 pi means the phase shift will be what? 1, and omega naught will be 1, right? So this is the graph of a cos t. Here we can observe one thing here. In discrete manner only replacement with t, right? X of n is equal to a cos omega naught n plus or minus pi. X of n a sin omega naught n plus or minus pi. There is only replacement with t means the discrete signal will be changes. Okay, then this is the one more example we can trace by using the graph also. Then you will get a cos t value, right? This is very important sinusoidal signal, because we know about that trigonometric equations like sine, cos values, or sine values, cos values, trigonometric values. Definitely we know about that sinusoidal signal, because it will become Fourier transforms or Laplace inverse transforms also. By using this sinusoidal signal you can get the trigonometric values also, trigonometric formulas. Thank you.